If we know the moment of inertia of a planar rigid body about a perpendicular axis passing through its center of mass, then we can find the moment of inertia about any other z-axis passing through some point P, and that axis is parallel to ZC. So if we start with a definition of the moment of inertia about this arbitrary axis, well, we can do some vector algebra to rewrite this using the dot product, which is the same as the squared magnitude of the vector r. And if we use vector addition, we can rewrite r. And now we can do some vector algebra to expand this dot product. And the dot product of a vector with itself is the same as the squared magnitude of that vector. And we can also split this up into three integrals. And now we can take the constants outside the integral while recognizing that the dot product is commutative. So we recognize that this term is the moment of inertia about the center of mass. And for this term, the integral evaluates the total mass of the body by the square of the distance to the z-axis passing through the center of mass. And this integral here evaluates to 0, because the radial vectors to the elements of mass in all directions will cancel each other out. And here is a visual. So we end up with the following general result.